now that we've explored multiplicative comparisons, we're going to be looking at how we might see them in a word problem. So we've seen those sentences just as a sentence, right? Like Sally's horse is, which is the equal sign, 3 times as many as 9 or something like that. So we've seen that just as a sentence, and now we're going to see that in more of like a word problem, so there's a little more background behind it. So I'm going to do my little quotations, which just means I'm repeating it, and I'm going to write with word problems. Okay, and we are on page 27. Okay, at this time, I want you to glue in or staple the notes that I sent home with you today. Leave some room at the top for our objective and our steps, and these are going to be the word problems that we are going to kind of take apart today. So once you've done that, unpause and let's get started. So let's write our objective for the day. So today I will multiply using comparisons. Double S. Comparisons in word problems. Okay, so let's look back at our notes really quickly from yesterday. So yesterday we looked at converting an equation into a comparison sentence. So we looked at how if we had 27 equals 3 times 9, we could say it in a comparison sentence by saying 27 is 3 times as many as 9. So we're just taking that and we're just adding a little bit of a story behind it just to make it a little more exciting, okay? Okay, so I'm going to put that up here just as a reminder. So let's just do 27 equals 3 times 9. And let's do our arrows. So 27 is 3 times as many as 9. So remember, it's just kind of like a little zigzag. 27 is 3 times as many as 9. Okay? So here are the steps that we can do to tackle more of a word problem using this comparison format. So let's write our steps. Okay, so step 1. What is being compared? So we want to think of who is involved in the word problem and what are they comparing. So here we can just kind of look and see, okay, we have a Brian, we have a Bob, and we have some oranges. So it looks like we're going to be comparing who has more or something like that. So just being able to recognize what you're comparing is the first step. Step 2 is write / draw the known info. Okay, so we want to see Brian has 40 oranges, so we would be like Brian equals 40 oranges. Bob equals 5 times much as Brian. So you just kind of connect like who has what oranges, what do we know about Bob's oranges, that kind of thing. Okay, and then step 3 is solve. So then we're going to solve it here. And then we're going to write a sentence. So let's look at this first one. Number 1, Brian picked 40 oranges. He picked 5 times as many oranges as Bob. How many oranges did Bob pick? Okay, so what is being compared? We know that Brian picked 40 oranges. So 1 and 2 kind of go together, right? So we could say Brian's, this is what we know. Brian's oranges are 40. So we know that Brian has 40 oranges. That's just a known fact. Brian has 40 oranges. He, meaning Brian, picked 5 times. We know that this times means multiply, right? Times as many as Bob. How many oranges did Bob pick? So you see we're missing this 9 right here. We're missing a number. We got to figure it out. We have an empty spot in our equation. So we know that Bob's oranges equal unknown, right? We don't know how many oranges Bob had. So we can go back up to here and we can kind of do a slash and we can say he picked 5 times as many as 5 times as Bob. Okay, so let's think of an equation. Brian picked 40 oranges. So that's our total. He picked 5 times as many oranges as Bob. So 5 times, we're missing that 9, right? Every time we say 3 times as many as, 5 times as many as Bob, we don't know how much Bob did. Okay, times as Bob. So we don't know how many. So this is where our multiplication facts come in. Very crucial. So when I look at this, I know that 5 times 8 gives me 40. So I can say that Bob picked 8 oranges. Okay, so here's my sentence. Bob picked 8 oranges. Let's just check. Brian picked 40 oranges. He picked 5 times as many oranges as Bob. So does 8 times 5 give me 40? It does, right? You could check by dividing. 40 divided by 5 gives you 8. So you know that's correct. Okay. That might be a little confusing, but let's work on some more. Number 2. The giraffe in the zoo is, we know what this means, is 3 times as tall as the zebra. So as tall as many as. So here we have our, probably going to be our missing variable, right? We don't have that number. The zebra is 7 feet tall. How tall is a giraffe? Okay, so we do know the zebra is 7. So we're not missing the zebra. We're missing the giraffe, right? So how tall is a giraffe? So here's what we know. So we have giraffe. So giraffe's height. Zebra's height. That's what's being compared. So we have giraffe's height and zebra heights. That's what's being compared. So let's write and draw the known info. Giraffe's height. The giraffe in the zoo is 3 times as tall as the zebra. So we can write 3 times the zebra. The zebra is 7 feet tall. So we have 7 feet. Okay, so let's think of an equation. The giraffe in the zoo is 3 times as tall as the zebra. The zebra is 7 feet tall. So our is missing, right? This is giraffe's height. Okay, equals, right? The giraffe in the zoo is 3 times as tall as the zebra. I thought the zebra's height was missing, but they actually told us that. The zebra is 7 feet tall, so times 7. So this is what my sentence could be. The giraffe is 7 times 3 is what? 21 feet tall. So let's check. The giraffe in the zoo is 3 times as tall as the zebra. The zebra is 7 feet tall. So I could put 21 is 3 times 7. Is that correct? Yeah, it's correct. We're good. Okay, let's look at another one together. Number 3, a single sunflower costs $4. A bunch of sunflowers costs $24. How many times as much does a bunch of sunflowers cost than the single sunflower? Okay, so what do we know? We know we have a single sunflower. I'm just going to put SF. And then we have a bunch. That's what's being compared. So a single would just be one flower. And a bunch would be like multiple. Those are my flowers. Okay. So we know, what do we know? Single sunflower cost $4. Bunch of sunflower cost $24. They want to know how many times as much does the bunch of sunflowers cost than the single sunflower. Okay, so we can do 24 is blank times as many as 4. So now we got to think of our facts. The bunches are, or the bunch is, blank times as many as 4. So 4 times what is going to give me 24? Well, I know that 4 times 6 gives me 24. So I can say a bunch costs 6 times as much as a single flower. Okay, so let's look at this again. A single sunflower costs $4. A bunch of sunflower costs $24. How many times as much does the bunch of sunflower cost than the single flower? 24 is 6 times as many as 4. Is that true? It is true. So our answer is correct. Okay, flip it over to the back and I'll give you some practice problems. Okay, these are the 2 problems I want you to work through tonight. So I'm just going to help you a little bit with the first one. So this is how it needs to go. A single piece of rope is, there's your equal sign, 5 times as long as a piece of ribbon. The ribbon is 7 inches long. Okay, so we know what this variable is, 7. How long is the piece of rope? So you want to think of what is being compared. We have single rope and we have single ribbon. What do we know? A single piece of rope is 5 times a ribbon. Ribbon is 7 inches. Okay, so what is your equation going to be? So something equals something times as many as blank. And then remember, you need a sentence. Okay, and do the same thing for 2 with Jimmy and his miles that he runs.